So this is 2022 ADDMA paper 1, question 10. Find the vector equation of a line through the points 2, 3 and 3, 1. So we can just call the points A and B. So the first thing you want to do, remember the vector equation of a line is given by R is equal to one of the points through which the given points are passing. So let's say that point is AI plus BJ, then plus, you can use any letter of your choice. In most cases we use lambda or mi or t, and then you can have the direction vector here. Let's say the direction vector is ci plus bj, then this will be your vector equation. So all we need to do here is to find the direction vector, the vector in the direction of AB, and then we can use one of these 2 points there and use that direction vector on this part here. So let's find the direction, the vector in the direction AB. So that vector will be, remember this is OA plus OB, and then our AO, remember this is 2A plus 3J, and then this is 2I plus J. So our AO will be the negative version of this. So 2I plus 3J plus our OB will be this one, 3I plus J. Then we can simplify this. I'll expand and then collect the like terms. So this will go with this. So we have an I, because this is 3I minus 2I, and then negative 3J plus J, this one will be 2J, like this. Of course this will be negative. So this is the direction vector we are looking for. Let's go. Okay, so now all we need is to pick another point along that line. Remember, according to the question, we want to find the vector equation of a line through the points this and this. So that means this point and this point are both passing through that line. So you can pick any of these two and say the vector equation is equal to R. If you pick this, your equation will be 2I plus 3J, then plus, let's use lambda. You put the lambda there, and then the direction vector like this, and you are done. Another one can use this point. So these two equations may look a bit different depending on which point you use, but with the right value of lambda, you realize that the two are actually the same. And then for part B, we have find the point of intersection of the lines with vector equations, this and this. So this is exactly what we do in coordinate geometry. When you want to find the point of intersection, you have to solve the two equations simultaneously. So in this case, we can solve these two equations simultaneously and find the value of m and the value of n. and then you can just substitute them back in and you'll be able to find the coordinates of intersection. I mean the points of the point of intersection of the two vectors. So to solve these two equations simultaneously, you can simply say, since these two are meeting somewhere, it means at that meeting point, if this is vector 1 and this is vector 1, then we have a point which is able to satisfy this and this equation simultaneously. So that means R1 is equal to R2. So this is all you need to do. Just equate these to R2, which is 1 plus 3ni plus 5nj. So let's equate them to each other and solve them simultaneously. 2 plus m, I think the j is supposed to be outside. Yes. And then we have 1 plus 3n I plus 5nj. So now to solve such a problem, you have to equate the coefficients of the i's and the coefficients of the j's. So you can equate these two and simplify. So when I take the one to the other side, it will subtract with that. So I'll just remain with m is equal to 3n, and then this will be my equation 1. To find our second equation, we can simply get 2m. Remember, the coefficients of j must also be the same, and then I can call this one my equation 2. So now to solve these two equations simultaneously, I can just substitute the m into this. So 2 plus m is 3n, and this is equal to 5n. Then we can just take the 3n to the other side, and then this minus this will be 2n. So that means our n is equal to 1. And then to find our m, I think it's much easier to use this. N is 1, so that means our m is a 3. So I can simply substitute my m in there to find those coordinates. If you want, you can substitute the n in this second equation. The answer will still be the same. So R1 is equal to this. So if I substitute my m here, then I'll get this. This plus this will be 4i, and then plus this one will be 5j. So these are my coordinates. If you want, you can still use this. The answer is still the same. So R1 is equal to, this is R2, 1 plus 3n I plus 5j, 5nj. So since our n is a 1, we have a 3 there, and we have a 5 there. So you add these two, you have 4i plus 5j. As you can see, it won't matter which equation you use, the answer will still be the same.